All right, hey Luke, this is the backside of 3-1 notes. We started functions and domain and range and all that good stuff on, they say you're faking sick. Anyway, we're on domain convention, okay? All right, this is the important part of this section, actually, the part that we're going to discuss a lot. Calc, we've just been discussing this I don't know, for the last chapter and a half, probably. Talking about domain. Not necessarily range, really, but domain is like what x's can I and can I not plug into this equation is basically what we're looking for, okay? And really, I've come up with kind of two restrictions, okay? Like two things that will happen that make your domain poop out, right? So if you have y equals, let's say y equals x squared plus 3x plus 5, I have no idea, right? That's going to be a parabola that probably is going to look maybe like this, right? And it's saying what's the domain? Okay, we know that from a graph, domain, we look at the x's and we say will he go left forever, will he go right forever, right? So what about this parabola? Will he go left forever and right forever? Yeah, as he goes up and out, he will go left and right forever. So the domain of that guy will be all reals, okay? So if it's just a quadratic function or anything like that, the domain will be all reals. I can plug any number in for x I want to into this equation and it will work, okay? But sometimes you have equations that don't work so nicely, okay? And they involve when you have a fraction, we never want to divide by 0, okay? So if I have 1 over x minus 3, we would say for the domain, x cannot be 3, right? This is the domain. We never want to divide by 0, so I can't plug 3 into that thing. Otherwise, I would end up with 0 in the denominator, and that's bad, okay? So can't divide by 0, and then the other one, what's the other one? A negative inside of a square root. So instead, I'm going to say, let's say we have example, the square root of x minus 3, right? Okay? Now, this domain error is a little bit harder to determine because it's not just x can't be 3. It's not just that, right? We have to, think about it a little bit, okay? So the way that I think about this is, I usually put it on a number line. And if I set x minus 3 equal to 0, we got that, x equals 3, right? I'm going to put 3 here, and then I'm going to test some points, okay? So let's test 0 and let's test 4, right? If I plug 0 in to that equation, 0 minus 3, I'm taking the square root of a negative 3, which is bad. I cannot have that, right? But if I plug 4 in, 4 minus 3 is 1. Can you take the square root of 1? Sure. So for this, you're going to actually have a domain that looks more like x is greater than 3, right? Rather than x is not equal to 3, you have x is greater than 3, okay? But can it be equal to 3?
Yes.
Can you plug 3 in exactly? 3 minus 3 is 0. Can you take the square root of 0?
Yes.
Yes, right? So it would be greater than or equal to 3. So the second domain error is a little bit harder to identify because it's a range of numbers. X can be any number bigger than 3. It's not that just it can be any number not 3, right? And not 3. It's a range of values, okay? So the second domain error when you have a square root is a little bit harder to do than the first one, okay? Does that make sense? First one, this division by 0 is easy. A negative inside of a square root is a little bit harder, okay? All right, so let's look at these guys. Let's see what we have over here. Here we go. Find the domain for each function below. A. We cannot have a division by 0. There's no square root here, but we don't want this bottom part to be equal to 0. So if you can't, in your brain, figure that out, figure out what x can't be, I just say x minus 1, which is that bottom, can't be 0, right? I don't want that equal to 0. And then we would add the 1 over, right? So x can't be 1. Now, some of you guys can do that mentally in your head and say x can't be 1. Good for you. That's fine. But if you can't, or let's say they give you something really gross, 1 over 5x minus 3. Then it's a little bit harder, right? I would say 5x minus 3 can't be 0, right? You would add the 3 over, right? 5x can't be 3, and then divide by 5, right? It's a little bit easier to do if you have an equation set up, ready to go. Okay, I just made that guy up, right? But if you can do it in your head, great. If not, just set it not equal to 0 and then solve, right? You undo the equation, right? X can't be 3/5. Good? That's A. B is going to be harder because B is a square root, right? So what can x, or in this case, u is our domain, right? What can u be and what can u not be, okay? So I always set him equal to 0 to start with, which means if we solve u is equal to negative 2. And then I use a number line to figure out what we can plug in and what we can't plug in, okay? So on this side of -2, let's test like -3. What about on this side of the -2? 0, okay? If I plug in a -3, -3 plus 2 is -1. Can you take the square root of a -1? No, okay? If I plug 0 in, 0 plus 2 is 2. Can you take the square root of 2? Yes, it's not nice. It's a decimal, right? But you can do it, right? So x, or u in this case, has to be greater than -2. Can it be -2 exactly? Yes, -2 plus 2 is 0, and we can take the square root of 0, so that is fine, okay? So do you see how a square root is a little bit harder than division by 0? Not as bad, kind of icky, right? Use the number line to figure that out, okay? Good, good? All right, now, we just said that there was 2 things that screw up domain. I'm going to add like a little half piece to this, okay? So we can't have, number 1, we never want to divide by 0. Number 2, we never want to have a negative inside of the square root. I'm going to say like 2.5. Rule number 2.5 is if you have a story problem, okay? So the only other thing that will screw up a domain is if you have a story problem. For example, like if we're talking about how many miles does it, whatever, right? How many miles? Well, you cannot have a negative number of miles, not even if you're traveling backwards in a car, like that's not a thing, right? You cannot have negative, you cannot have negative time. So sometimes that will restrict your domain as well in a story problem, okay? And I'm going to say usually involves negative numbers. Like we cannot have negative values, okay? Or like the other day, I think we had a story problem where it said like we can only, and maybe this was in calc, tell me, we can only hold 450 units on our truck that we're hauling. Was that in calc? Okay, so in that case, our domain would be restricted by 0, because we're talking about the number of units our truck is hauling. We can't have less than 0 units that we're hauling. I can't have like a -4 boxes. That's not going to work. But then our upper limit is like our truck will only hold 450 boxes. So we're restricted between 0 and 450. That's kind of what our domain looks like, okay? So sometimes usually involves negative numbers that we can't have, but also could involve an upper limit as well, okay? All right, so a glassware factory has fixed expenses like mortgage, taxes, machinery, those type of things that amount to $12,000 per week. That is insane. We better be making lots of money. If it's $12,000 per week is what our cost is. In addition, it costs 80 cents to make 1 cup, and a cup sells for $1.95. At most, 1,800 cups can be manufactured each week. Okay? Express the revenue as a function of X. So our money that we have coming in is how much? $1.95. X. Is that all the revenue we have coming in?
No, minus 80x.
No. We're not putting them together yet. Because we have a revenue. That's the only money that I have coming in, right? $1.95 per unit. That's all the money I have coming in. Now the cost that I have, okay, it's costing me 80 cents a thing, right? Okay, keep going. You're doing fine.
Negative 80x.
I'm just going to call it 80x. Point 80x.
Plus 12,000.
And I'm going to say plus 12,000. Now, if we are going to then like combine the two, it would be like this equation minus this equation. So that's why you're saying minus 80x. Okay. But cost, we're just going to put as a positive number, and then we would subtract the two. Okay. So that's kind of how that would work. So there's our cost equation. Find the rule and the domain for weekly profit. Okay. Profit is equal to revenue minus cost. Okay. So if I put those two equations together, my revenue, which was $1.95 per item, that guy, we're going to subtract out our cost, which is 80 cents X plus 1,200, right? 12,000. Okay. If I put those together and I distribute that negative through, okay, this would be negative 80 cents X minus 1,200. So my profit equation would be something like what? If I put my x's together, 1.95x minus 80x, what's that going to be? 1.15x minus 1,200, right? Okay. Then I can figure out, like from there, I have this equation for my profit. I could figure out like my break-even point. Do you know what break-even is? Like how many items do I have to sell in order to like make $0 for my profit to like cancel out, like my revenues and my costs. And I would plug 0 in for this guy, right? Okay, so like how many items I would have to sell. Somebody take 12,000 and divide by 1.15 for me, would you? 12,000 divided by 1.15. If I actually do that.
10,434 and 78 cents.
Well, it's not cents. So it would be like basically, if I round up, 5 items. I would have to produce 10,435 items before I even start making a profit. Like this is like me canceling out my costs. Okay? As soon as I do that 6th one, I start to finally make like $1.95. Woo! I'm out of the hole after I do 10,436 items.
What do you want to make, $1.15?
$1.50.
It costs 80 cents to make
Right. $1.15 technically is what I would make. Yes. Good point. Okay. Yes. So there's that. Now, find the rule and the domain for the weekly profit. So this is my rule for my profit, right? Rule. But then I want domain. Okay. So how much are we allowed to sell and how much are we not allowed to? How much are we allowed to produce? Like my minimum versus my maximum. What's the minimum number of cups that I'm allowed to produce?
10,000, whatever.
Now, I could produce less than that. I'm just not going to make a profit, right? But what's like the absolute minimum I can produce? 0, right? I could produce 0, right? So it's going 0 all the way up through 18,000. That's my upper limit, right? I can't produce any more than 18,000, yeah? Okay? Good. Now, if you want to write it in interval notation, it would be brackets like this guy. This means the same thing. I don't care how you write it. Okay? Now, let's say, best case scenario, we're producing 18,000, right? Somebody plug that in real quick if you have a calculator. What's 18,000 times 1.15 minus 12,000? Do that really quick for me.
8,700.
8,700?
Yes, $8,700.
Holy crap. So, maximum amount I can make per week is $8,700.
Times 52 weeks in a year, $452,400.
452,400. Okay, that's per year. But that's how much like the whole production company is making. I hope I only have like 1 employee. Right? Like that would really suck. Okay? Because that's not a whole lot of money I'm making per year if I'm doing like a whole factory producing. If I'm producing 18,000 items a week out of this factory and I'm only making 452,000 a year, like that's I mean like maybe whatever we're producing is small. What are we making? Cups?
It says 80 cents to make 1 cup. Labor, something, materials, and shipping. So
Yeah, that's crazy. 12,000 per week. That's a lot of costs if I'm only making 80. Like I'm costing more than I'm making per week. Does that make sense? Like my costs are taking up like 75% and I'm making like maybe a 25% profit. That sucks. We need to reconfigure some things. Like cut down on labor, fire some people. I don't know. Like that's how that works, right? Okay? All right, these are decisions people have to make in management, right? Like they crunch these numbers and they're like, woo, if we're like not making that much money, like we need to do something, okay? All right, so there's that. That was example 7. Okay, example 8. You may or may not have seen a piecewise function before. A piecewise function is like 2 functions at the same time, like going on, right? So here I have 2 different rules that we have to follow. Now, this right here is what my domain is, okay? We're going to talk about that domain combined. This is the domain. So if what I'm trying to plug in is a number that is less than 4, I'm going to plug it in here. If that number is a number between 4 and 10, I'm going to plug it in here. Okay? What happens if that number is bigger than 10?
It doesn't fall in any category.
It doesn't fall into any category, so what do I do?
None.
It has no answer. Like you cannot plug in numbers that are bigger than 10. That has to do with the domain. That's like our restriction, right? Okay? All right, so f of -5. Which equation are we going to plug into? The top one or the bottom one? The top one. -5 is a number that is less than 4, so I'm going to plug into the top one. So I do 2 times -5 plus 3. What's that become? -7. Okay? f of 8. 8 falls in the second category, so we're going to do 8 squared minus 1, which is 63. Okay, then they say the domain of f. All right, this is the domain. If I combine those together, am I allowed to plug in any negative numbers I want? Yes. Am I allowed to plug in any positive numbers I want? Only up to 10, right? Like I can plug in any number less than 4. I can plug in any number between 4 and 10. But 10 is the highest number I can plug in. So basically, if I lump those two together, if I smash them together, the domain will be only x's that are less than or equal to 10. Or you can say from negative infinity to 10. Those are only the numbers I'm allowed to plug in. Oh, 10, is he equal to or not equal to? Equal to, because he's like there. Okay, what if I'm plugging, real quick, what if I'm plugging 4 in exactly? Do I use the top one or the bottom one? The bottom one, because it's equal to 4 here where it's not equal to 4 there, right? Let's say
4 is, like, the top one is also equal to 4.
You can't have both the top and the bottom equations equal to 4. One of them has to be an open circle, one of them is a closed circle. Yep, they won't allow you to do that. Now, in calc, when we start to do limits, and to figure out whether a function is continuous or not, you are going to actually plug 4 into the top and the bottom to see what the y-coordinate of each one is to see if they connect, right? We'll talk about that at some point. But that's the only scenario where you will plug that 4 into the top and the bottom. But we'll get to that, okay? All right, so there's that. Good? I don't care how you write the domain, x is less than or equal to 10 or negative 10 to, or negative infinity to 10. Either way, I don't care. Okay, good? All right, greatest integer function. This is the last one, greatest integer function. I will not test you over greatest integer. It is not a function that you will see very often, but it's kind of a fun one, okay? This is what the calc book. You guys just had this the other day. On Friday, we did greatest integer function where we graphed it. That's like the age, the age you are. Okay, now, do you remember the way that the calc book notes it? They don't use the same notation like this. The way that they use the way that they do it in the calc book is f of x equals, they do a double bracket x. Do you remember that?
Yeah.
Okay, so if you see this or if you see just the bracket around the x, make sure that you know that like that's not absolute value, it's a bracket, right? Okay, that means the greatest integer function. Okay, so let me show you what greatest integer looks like. You won't have to graph it, but like this is what it means. Ready? Greatest integer function goes like this, and it goes over to 1. This is like 1 on the x-axis. Then it bumps up to 2, bumps up to 3, open circle, bumps up to 4, and this is what it looks like. Okay, this is how I describe the greatest integer function, all right? This is at 1, this is at 2, this is at 3, etc., right? Like that's how that works, okay? Here's how this works. It is a solid bar all the way across until you get to the next integer, then it bumps up to 1, right? Okay, so a baby that is 9 months old. Let's say you're 9 months old, so you're like right here on the spectrum, right? You are still 0 years old, right? You do not reach 1 year old until your birthday when you jump up to be 1 year old, right? And then let's say you are 1 year old and 1 month old. You are still only 1 year old until you get to your second birthday, and then you bump up to 2 years old. And then you are 2 years old for an entire year, and even the day before your birthday, you are still only 2 years old until your birthday, and then you bump up to 3 years old. Does that make sense? So the greatest integer function, no matter where you're at, you could be, how old are you guys in here? 16? 16, almost 17 years old probably. You could be 16 years old and 364 days, which means your birthday is tomorrow, and you are still only 16 years old, sorry. You can say my birthday's tomorrow, but you're still only 16, right? Like you're still 16 for that one more day, right? Okay, so that's the way that the greatest integer function looks. Like everything rounds down. So it's like 16.9 rounds down to 16. 17.1 rounds down to 17. Okay, everything rounds down to that number, all right? Now, it gets really complicated when you're dealing with negative numbers. If I'm rounding down on a negative number, okay, like think of a number line, right? Here's -6, here's -5, here's -4, here's -3. -4.7 lives about there. If I round him down, what does he round down to? -5, okay? Like if he's a negative number, he rounds down to -5. Does that make sense? If that was a positive 4.7, it would be rounding down to 4, right? But since it's negative, it's rounding down to -5. Make sense? Negative numbers are kind of weird, okay? What does -3 round down to? -3. That's like on your 3rd birthday, you're going to be like 3 years old, right? Okay, what does f of 0 round down to? 0. If it's a whole number, it just stays that whole number. What about 5.4 as a decimal? 1.25. It's going to round down to 1. What about pi? It rounds down to 3, right? So greatest integer function, everything is rounding down, okay? It's not too terrible of a function. Like, it's kind of cool, but we just don't deal with it very often, so I don't make you test on it, okay? Good. That is all that I have. Okay, you guys have a worksheet. Yay! No more book assignments for the rest of the chapter, at least. I think from here on out we are out of the book, which is kind of exciting.
So we don't need a book.
No, you don't need your books for like the extended time period for a while. Like, I will tell you if you ever need your book again.
Ever again?
I won't say ever again because we may use it like a little bit. But what?
Can you come help me?
So there's that. Okay. All right. Anything else? Any other questions for the good of the cause?
No.
Okay. Goodbye, Luke.